Hello and welcome to this next lesson where we will be looking at subqueries. Okay, so the idea of a subquery is that we will have a query within or inside another query. So we will have an outer query and we will have an inner query. And so you might be asking, why do we need to have subqueries? Well, it turns out that there are instances where uh, it's easier, it's more straightforward to use a subquery. And so I want to use this example to demonstrate how to use a subquery. Okay, so for this I decided to create a table, two tables, one named student and one named grade. It's a one-to-many relationship. I am assuming that for each student, um, that student can be found in the grade table many times. And what is in the grade table? Well, it's the student's GPA per semester. So as you know, each semester you have a GPA, and that GPA might go up or down um, depending on your semester. All right. So we have our student table has ID, serial, first name, last name, and a gender. Now there's something new if you notice that I use the check command. And the check command is a constraint. Okay, so it's a constraint. Okay. Similar to not null or primary key. Right? When the DBMS sees these constraints, it knows that, for example, first name cannot be empty. So that's a constraint. We call it a constraint. Okay. So you can manually set a constraint by using the check keyword. So I'm going to say I want you to check the gender column, okay, and make sure that for every row that is going to be inserted into student, right, the first name cannot be empty, the last name cannot be empty. However, the gender must be either this word male or this word female. And so I am saying check that gender is in male, comma, female. Okay. So I have my student, first name, last name, gender. And for the first two rows, I insert properly. But for the third, I insert none, which should trigger this constraint. And so I want to show you what exactly happens when this constraint is triggered. Okay, we move on to the grade table. And I have ID serial, student ID, which is our foreign key. Remember, this is my foreign key. Okay, this key is the one that links us back to the parent table. And I have a semester column, which is integer, semester 1, semester 2, semester 3. And then I have a GPA. Now GPA, since it can have decimal numbers, I will use the numeric type. Okay, so we use numeric type when you want to express decimal numbers, decimal points. And so what I'm saying is 3, 2, the 2 simply means the number of decimal places that can come after. And the 3 simply tells the DBMS that that's how wide the word, not the word, sorry, the value can be. So if you know this, I have 3.50, 2.88, 3.25 because GPAs, the maximum they can be is 3 digits, right? And so that's why I have a 3 here, maximum of 3 digits. And I can have a maximum of 2 decimal points, up 2 decimal numbers, 2 numbers, sorry, after the decimal point. So for example, if I decided to put a 9 here, the DBMS would simply round it to 8, 9. All right. Okay, so what I want to do is to load this these tables and their data into my database. So I went ahead and I created a week 7 database. All right, currently there are no tables in there. All right. Remember, tables and relations are the same thing. Okay, so let me go ahead and I'm going to load my GPA data. Okay, and so it's telling me, okay, student does not exist. Error. I have a constraint error. So it's telling me that none cannot work. All right, and so it stops right there. So if I check if I have any tables, I have tables, but do I have anything in there? Great. Right? Nothing was added. All right, so it doesn't add it. Student. Okay, nothing was added. So we need to fix our constraint error. So let's come here, let's fix this, and let's put it as female. All right, and so this is good because it helps us to make sure that we only accept good data. Right. So for example, if I wanted to make sure that the GPA was less than or equals to 4, I could have done that. I could have said something like check that GPA less than or equals to 4 and greater than or equals to 0, right? Because the GPA is from 0 to 4.0. You can't have a negative GPA. You can't have a GPA more than 4. So that's where we would put another check if we wanted. Okay, and of course we could also check to make sure that semester was either 1, 2, or 3. All right, so those are constraints. But for now, I just want to show you how to do it for male and female. All right, so let's run our file again. All right, so let's verify that we have our data in. Okay, we got our data in. Great, we got our data in. So let's now talk about the subquery aspect. So what I want to do, let's say the person who you work for, or just you want to find out which or what is the count. Okay, let me come back here. Oops. How many students have a GPA that is greater than the average GPA seen so far? Okay, so in other words, I want to find out, I want to ask the DBMS, I want to ask Postgres. I want you to get all these GPAs, I want you to find the average of them, and then I want you to show me all the students who have a GPA greater than the average GPA. And then I also want you to tell me how many of those students there are. It's quite a mouthful. So the way we think of it is we solve this problem a piece at a time. So what's the easiest thing to do? Find the average GPA. That seems easy enough, right? So all I'm going to do is to say select. How do you find the average? AVG. All right. GPA from grade. That's it. Okay, let's run this. All right, so the average GPA is 3.5. 3.405000. All right, great. So we have the average GPA. Now one option is I could get this value 3.405 and I could write a query that says select say s dot first name. What else do we need? Let's say s dot last name. Let's say g dot GPA from, so I'm gonna do a join, right? Student as s, inner join, grade as g on, well, s.id, and the foreign key is g.student id, where g.gpa is greater than, and then I might say, what is it? 3.405. 3.405. Okay, let's see if we get something. All right, we get some names. Great. Now, let's say we have more grades, more GPAs. And so we add in another GPA. Right? We add in 10 more GPAs. What does that mean? That's a consequence of adding more GPAs, more rows to my grades table. It means that the average GPA will change. And what does that mean? It means I have to go back and I have to manually run this query to find the average GPA. Okay? Now, instead of having to manually put in this value, so I'd have to run this query to get the GPA, copy it from here, paste it in here, and then run this query. Not very scalable. Okay, what if the GPA changes every 2 weeks? Or let's think outside the box. What if it's not GPA I'm finding? What if it's something I'm finding which changes every minute? Or changes at the end of every day? For example, what was the largest purchase order today at a business? Today it might be $1,000. Tomorrow it might be $600. So you don't want to have to be going back and changing your core parameters. So a better solution would be a subquery. So what I'm going to do, I'm going to remove this hard-coded value, and I'm going to say, you know what? Why don't I just ask the DBMS to do the hard job for me? And so all I'm going to do is to say, okay, where g.gpa greater than whatever this query returns. So as far as the DBMS is concerned, it will evaluate the subquery. All right. Okay, let me close it. Okay. All right. So good. So it will say, okay, let me evaluate this. Notice I put the subquery in parentheses. Okay. And so this semicolon has to be removed. Right. Remove the semicolon. Because in reality, the statement doesn't end here. The SQL statement ends here. Right? It ends here. That's the last statement. So if you think about it, all of this, let me not put the semicolon right now. If you think about it, all of this will evaluate to some number. And then the DBMS will use that number as the value here. right? As the value here. And so this is what I mean by a subquery. It's a query within another query. And so this subquery will give me the average, and then I will use that average to find the larger query or the outer query. And that's what I mean by a subquery. And so let's run this. Okay, so notice I put my semicolon because this is the last statement in the query. All right, so we do this, where GPA greater than this, N SQL statement. So let me try again and let me see if I get the same answer. I get the same answer. Okay, so now it doesn't matter if I add more values. So let's say I decide to add another row. Let's say student 3, semester 3, got a GPA of, let's say it bumped it up to 4.0 for some reason, was studying hard. Okay, and so now our average should change. And so let's see if that affects what is returned. Okay, and we have different values. Right? We have different values. Okay, so as you can see, we didn't have to tinker around or change anything because the subquery did that for us. Now, that's the first part. Now let's think about this. I have the average GPA. Good. And how many students have a GPA that is greater than the average GPA? That's what this does. That's what this does. Okay. That's what this does. So this tells me the students who have a GPA greater than the GPA, average GPA seen so far. Now let's answer the last part, which is how many students are they? How many students are they? How many students have a GPA that is higher than the average GPA? Now you might be thinking, let's just tack on a count to count the number of rows. But you will be unpleasantly surprised. It's telling me that I have to use a group by. Okay. So I don't really want to use a group by. What if we do this instead? Since we're using subqueries, why not make all of this be a subquery, right? Because what does this do? All of this does, it gives me back, oops, let me save this. All of that query gives me back a table, right? This is a table. And I can count the number of rows. So why don't I consider that entire thing a subquery? And then I could just say select count. So let's do that. So again, you need to use a bit of abstraction. I want you to imagine that all of this is just one query. And let me copy it, by the way. Let's copy it and let's put it down here. Right. So it's gonna solve this big problem here, which is count the number of rows that we got from up here. So all I want to do, I want to say, okay, well, select the count number of rows. Okay. If I want, I could say count, what do you call it? GPA. Right? Let's just count GPA if we want. Okay, so count the number of GPA rows from, and I know I need a table after from, right? So all I'm going to do is put parentheses around this. So I'm going to select the count number of rows from this. But if you recall, this is actually a table. And if you remember from SQL, whenever you have from, it's from some table. So as far as we are concerned, this is a table. So I could ask to count the number of rows from the table that is returned from this query. Now, let's run this. Okay, so our semicolon goes at the end. All right. And if we do that, all right, so it's telling me subquery in from must have an alias. So it turns out that when I use a subquery as a table, I have to give it an alias. Okay, so let's give it an alias. Let's call it temp. Okay, that's it. All right, remember SQL, there are certain rules. Okay, so let's try again. Okay, and there we have it. We have 5 as the number of rows, right? And of course, this is very this is scalable. So if you have 2,000 students, then you can easily get how many students there are who this semester got above the average GPA without having to change this code. All right. And so that's the reason why we have subqueries. So again, I started out with one query, and then I added a subquery to get the average. And then I decided to make this subquery, which consists of a subquery itself, become a subquery to the select count. So it's a subquery within a subquery. All right. And you can extend this up and up and up and up and up and up. The only thing with subqueries, they take some computational time, meaning that you don't want to have too many subqueries because they kind of slow down how fast the DBMS gives you back the answer. Okay, but there are instances where using a subquery makes your SQL code less confusing, less complex. All right, and so sometimes we want to use subqueries. And so this is one instance where using a subquery makes more sense, right? Instead of having to manually get the values, then you just do a subquery, and the DBMS does the hard lifting for you. All right, so that takes care of subqueries. The key idea is, instead of having to manually do the steps, you simply use subqueries, and the DBMS will generate the intermediate values for you that will be used in the outer queries. All right, brings us to the end of this lesson, and I will see you in the next one.